This video is for lesson 7 in geometry, and we're just going to be looking at more problems that involve the equation of circles. So in the xy plane, the graph of the equation x plus 2 squared plus y minus 4 squared equals 25 is a circle. Point P is on the circle and has coordinates 2, 7. If PQ is the diameter of the circle, what are the coordinates of point Q? So I got this question from an SAT test, and I just thought that it was a perfect example of how the SAT tests the math that you learn, but they always find kind of a tricky way to ask the question. And then they don't give you a graph to make a nice neat graph of the circle, so you would just have to know to make a graph in order to answer the question. So the first thing that I would do is make sure that you know the center and the radius of this circle, which would be -2 and +4, and the radius, since the radius squared is 25, the radius is 5. So let's graph that circle over -2 and up 4 with a radius of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So those 4 points form the circle, and then supposedly also 2, 7. 1, 2, 3, 4, 5, 6, 7 is also on the circle. So I'm going to go ahead and try to sketch that circle. It's not a very good looking circle. All right, so then this point P is on the circle, so this is point P, and PQ is a diameter of the circle, and the question wants to know the coordinates of Q. So let me grab my straight edge and draw the diameter. And I at least know 2 points that are on the diameter already, because the diameter has to go through the center and it has to go through point P. And so this looks like it's probably the point Q. My sketch does look like it goes through that point, but you could double check it, because this is up 3 and over 4 from the center, and so the other end of the diameter would have to be down 3 and over 4. Doesn't really matter whether it's whether you think of it as positive or negative, to get that. So I can tell now that the point Q is 1, 2, 3, 4, 5, 6 units over and 1 unit up. So Q is equal to 6, 1. So there you go. And I think in the SAT question that was similar to this was actually a multiple choice question, and so 6, 1 would have been one of the choices. All right, next question was also from an SAT test. The equation x squared plus y squared minus 2x is equal to 3 is a circle in the xy plane. What is the radius of the circle? So they don't tell you to put the circle into standard form, but you can't tell what the center is or the radius is without doing that. So I'm going to set up the completing the square. And then it's also a little tricky because there's no y term, so I don't actually have to complete the square for the y. I don't have a y term, so y squared is already good to go. And then there's a 3 and a plus blank. And then to figure out what goes in this blank, I'll put a -2x on the bottom. The two sides have to combine to -2x and be the same. And so they must be 1 and 1, -1 and -1. And then when I multiply these times itself, I get +1x squared. So a 1 goes in this blank, and a 1 goes in this blank. And then I'm going to go ahead and finish putting it in standard form. this would come out to be 1x minus 1 squared plus y squared is equal to 4. And so if it was asking me for the center, I would know that the center is at positive 1 and 0. Since there's no parenthesis with the variable there, you could think of this as y plus 0 squared. And then the radius, this value represents the radius squared, so the radius is 2. And that is the answer to the question, what is the radius of the circle? So you might not have bothered to get this entire standard form of the circle, but I think it's good practice anyway. All right, so number 3 is to find the equation of the circle shown. And in order to do that, you need to know what the center is. And it doesn't look like the center is given, but it is given because it would have to be right here. Looks like the graph goes through 0, 0 and 0, 8. And so the center is just the midpoint of those two. And it's pretty obvious that it's 0, 4, but you could always add the two endpoints together and divide by 2. But once I have that, then I know that the center is 0, 4, and then I also know that the radius is 4. So when I go to write the equation of the circle, I'm going to have x and something squared and y and something squared is equal to the radius squared. I know that the radius squared is going to be that. The x value of the center is 0, so I can put in a plus 0 or a minus 0 there, it wouldn't matter. And then the y value of the center is 4, and remember that they're always backwards, so since this is a positive 4, that needs to be a negative 4. So if I clean this up, it will be x squared plus y minus 4 squared is equal to 16. Then the next one is to solve the system of equations by substitution and to label the solutions on the graph. So in this problem, I'm going to first off point out x squared plus y squared equals 10 is this circle, and y equals 3x is this line. And when we solve the system, we're going to end up finding the coordinates of those 2 points. So I'm going to take this expression y equals 3x and substitute it in for the y in the x squared plus something squared is equal to 10, and I'm going to put 3x in there. And so this is x squared, and 3x squared means 3x times 3x, which is x squared plus 9x squared. And x squared plus 9x squared is 10x squared. So then x squared, if I divide both sides by 10, is 1. And then x equals plus or minus the square root of 1. And the square root of 1 is just 1. So then that means that I know that the coordinates of these points are plus or minus 1. So this one is obviously positive 1, the x value, and this one, the x value, is negative 1. And then to get the y value that goes with those, I can use either one of these equations to get the y coordinate. So if x equals 1, then y is equal to 3 times 1, or 3. So when x equals 1, the y coordinate is 3. And if x equals -1, then the y coordinate is -3. All right, so that's solving a system that involves a circle. And one last question here, a bit of a challenge question, I think, but still good. So if you're hanging in there, let's go ahead and do this problem. It says find the equation of the line tangent to the circle from problem 4 at the point 1, 3. So I would be looking for a line, the equation of this line I'm going to draw here in green. And what I know about that line, I didn't draw it very well, but I know that that has to be perpendicular since it's a tangent line. So the slope of the diameter here, the slope of the pink line is up 3 and over 1, which means that the perpendicular slope has to be the opposite sign, so negative, and the reciprocal. That's the slope of the green line. And then I know it goes through the point x1, y1, 1, 3, and has this slope. So y minus y1 is my point slope formula. And I'm going to use -1/3 for the slope, and I'm going to use 1 and 3 for the x1 and the y1. So this will be y minus 3 equals -1/3 x minus 1. So that technically is the equation of the green line up there. If we put it into y equals mx plus b form, it'll get a little tricky with the fractions, but nothing that you shouldn't be able to handle. So I need to add 3 to both sides. And so I can say y, I'm just going to recopy this, -1/3 x plus 1/3. And then if I add 3 to both sides, then I will get y equals -1/3 x plus, I could take the easy route and just say 3 1/3, but I would rather take my 1/3 and add 3 over 1. That would be 1/3 plus 9/3, making a common denominator there, which would be 10/3. So I'm going to say that this is -1/3 x plus 10/3. And it would be great practice or checking for you to put this whole thing into Desmos and see that it all works out nicely. Super satisfying. I'm not going to do it on the video right now, but I would encourage you to graph this equation, and you'll be able to check these points of intersection, and then you can graph this equation, and it should touch the circle right there at 1, 3. You should do it. Thanks for watching.